A hiker leaves a footprint on a trail. What footprint does a cheeseburger leave? Futurist Jimé Cassio calculated that the carbon footprint of the cheeseburgers consumed in the United States per year works out to 195,750,000 metric tons of CO2 equivalent, equal to the carbon emissions of 19.6 million Hummer H3 SUVs. A footprint is a measure of the life cycle use and impact on resources, such as energy, water, and systems, like the productive capacity of arable land, generated in the production and use of a given item. Or it can be a measurement of impact on environmental factors like carbon emissions, waste, or toxins. Footprinting can be used on large systems such as national water use or corporate carbon emissions. Or it can be used for individual products, such as that cheeseburger. It can be used for specific resources such as carbon or water footprints, or to gauge more holistic impacts, such as an ecological footprint, which is a measure of how much of Earth's finite land and water surface area is impacted by a product or activity. Tracking footprints helps you know where you stand in relation to your competitors, or to policy goals, or to your own goals. Before New Belgium Brewing Company developed a carbon footprint of a six-pack of its Fat Tire Amber Ale in 2007, the company assumed transportation and shipping had the biggest impact and was therefore the best target for reducing carbon emissions. The analysis delivered surprising and strategically significant results. Transportation came in unexpectedly low at fourth place, after glass bottle manufacturing, growing hops and barley, and refrigeration. Now, New Belgium is focusing on using higher recycled content in its bottles and is considering using organic and less carbon-intensive ingredients and is jumping ahead of both competitors and emerging carbon regulations. Embedded in the concept of a footprint is the concept of a product life cycle. The footprint is the measurement itself. The product life cycle is a conceptual tool that helps us identify where to look for impact. People tend to think of products as they exist in the moment they use them, and rarely stop to think about where they came from, what they are made of, or where they will go when their useful life has ended. Take, for example, this simple pen, something people may use every day. Do you really know much about where it came from, or where it may go after you use it? If prompted, you might extend your view of the product to the stage immediately before and after you use it. You purchase the product from somewhere. You'll eventually dispose of it somehow. Extending the concept of a product to think of its distribution and disposal is a start toward understanding its life cycle. The product life cycle is an essential concept in green business because products impact the environment at every stage of their existence. But the product life cycle actually extends back further than when we purchase a product. The product first has to be manufactured, and before it can be manufactured, the materials needed to manufacture it have to be acquired from the earth through mining, drilling, harvesting, or other processes. The full product life cycle includes 5 states: extraction, manufacturing, distribution, use, disposal. Click on each of the stages in the diagram to see common green implications for each stage. Raw materials can be gathered from the earth in a multitude of ways. In addition to the materials that physically compose a product, manufacturing requires energy, water, and other process inputs. Distribution is the process of bringing raw materials to factories and transporting finished goods to market. Many products require chemical or energy inputs to function, and then release chemicals or other outputs as they are used. The most common way to dispose of products is to dump them, either on land or in the ocean. When it comes to the environmental impact of products, it's important to recognize that a product is typically composed of various components. For example, a pen has parts that are plastic, metal, and chemical, the ink. In addition to the pen's life cycle, each of these components goes through all 5 stages of the life cycle as well. The product life cycle can provide a better picture of the true consequences of the things society produces, uses, or consumes. But developing a green perspective involves looking at more than just obvious first-order consequences. It's more like peeling an onion, where each layer reveals another. Creating a product requires other products. For instance, the extraction stage requires equipment to mine or refine natural resources. Manufacturing equipment is also a product with its own product life cycle, complete with resource demands and environmental impacts at each stage. At each stage of the product life cycle, you will see a complex system of interacting components. Consider the product life cycles of components needed at each stage, and you get a complex set of interactions potentially going back many generations. A change in one part of this system of systems not only affects the immediate product life cycle stage, but can have repercussions that ripple out to affect other parts of the system. Because of the complex relationships, a change in any part of a system can lead to unexpected outcomes. Because of all this, it's not feasible to precisely calculate the complete environmental impact of a product. But it is possible to look beyond the immediate, direct impact and think about how design changes will ripple through the first generation or two of the chain, and to calculate this impact using life cycle analysis, or LCA. Looking at the complex relationship between elements in a system is called taking a whole systems view. A whole systems view recognizes that assessing environmental impact requires looking at the interconnected systems involved in manufacturing and business operations. Please complete all questions in this assessment and submit your responses.